Okay, welcome back, guys. We're going to continue with our stuff regarding senses as far as our material. So we didn't do too much yesterday, right? It was just basics, getting familiar. But we're going to continue moving forward, especially with two of the particular senses that we need to talk about today. So first of all, here we're able to see, when you're looking at the brain, what different parts of the brain control different regions, which is what was talked about in the previous video, right? Color coding, make it nice and easy to spot a lot of stuff, auditory cortex, occipital lobe, parietal lobe, gustatory cortex, olfactory, etc. Pretty useful. All right, so let's talk about our sense of touch, right? Remember that touch has another name. It's also known as somatosensation. So keep that in mind. The nerve endings in your skin can tell you if something is hot, cold, smooth, or rough. They can also feel if something is hurting you. Your body has about 20 different types of nerve endings that all send messages to your brain. So your sense of touch is actually rather intricate. It provides a lot of information. We're not going to learn all 20 of those receptors. We're just going to talk about 4. We're going to talk about these 4. Mechanoreceptors are going to be identifying pressure, vibration, and texture. So that's obviously purely mechanical, right? Most of that's common sense. Thermoreceptor, I think thermometer, that's all about temperature, right? Nociceptor, these are kind of weird. So noci is Latin for pain. So noci, or Latin for injury or hurt. So nociceptors is going to be all about pain. Obviously, you want to have a sense of pain so that you know that your body's hurting. So you can mend it, you can tend to it, right? The last one, which is in my opinion the most important one, proprioceptors. Proprioceptors are useful for the position of the body in relationship to each other and the environment. Super important for things like feeding and clothing oneself as well. So one of the best ways to test your proprioception, if you have your arms spread out like so, you have your hands like little L's. If you touch your fingers together, right, that's easy, no problem. But if I were to close my eyes and touch my fingers together, notice how I still got pretty close, right? It's because I always know where my body parts are, regardless if my eyes are closed and I don't see them. So that's what proprioception is all about. Very, very important. In my opinion, the most important aspect of touch for the human body. A little bit more about touch, and this is a great experiment you can try at home. Honestly, it just takes more than one person. If you have another person to help you, you can use it. You can use toothpicks. You can use a pen, as long as you're not writing on the person, a fork if you wanted. Different parts of your body have higher sensitivity to touch based on density of mechanoreceptors. For example, the tip of your finger is much more sensitive than your upper arm. So I know a ton of people that when they do the prick test, which is like a little box that you put up to your finger, a needle injects into your finger, draws some blood, and then it's useful for testing like blood sugar. A lot of people hate that test, but they're more comfortable with like donating blood, right? Or a vaccine, which would happen in the arm area. So again, you could do this example with someone else if you like. It's fun. It's a good example or a good experiment. Okay, up next, we have taste. Remember that taste has another name. Taste is also known as gustation. So if I were to ask you on the test, hey, what organ is the main organ for for touch? It would be, of course, the skin. The main organ for taste is going to be the tongue, of course. Now, the tongue is the major taste organ, like we said. It has a bunch of bumps called papillae. You can physically see those bumps on your tongue if you were to look at your tongue in a mirror or even using your phone camera, right? Majority of these papillae contain 2,000 to 5,000 taste buds. So your tongue is covered in taste buds in order to observe your sense of taste, which we expect, right? Here we see the diagram of the tongue, by the way. We don't need to worry too much about the anatomy of the tongue. Not too necessary. Now, there are 5 established tastes. Now, this gets a little complicated. That's why we call the sense of taste gustation. So if we're talking about the sense, that's gustation. If we're talking about what we can actually taste when you're eating food or drinking liquids, that is going to be just your tastes. So what are the 5 established tastes that we observe? Sweet, that's an easiest one. Sour, bitter, salty, right? Those are the ones that a lot of us already know. The one that is a little bit tricky is umami. That was discovered in the early 1900s, 1907, around that time period. Umami was discovered by Japanese scientists. So roughly in English, it translates to savory. Foods like meat, especially beef and pork, have a ton of umami. Tomatoes, mushrooms, those foods also have a lot of umami as well. So those are foods that you can compare to. You might be thinking, wait, isn't spicy considered to be also part of your taste? Not exactly. It turns out that spicy is just pain. It's pain on your tongue. It just so happens that some of us enjoy some of that pain, right? In 2015, Purdue University suggested a new taste called Oleogustus. I actually looked into this recently because that was 6 years ago. It still seems to be in the research stage, but it would be considered the sixth taste if it's valid, specific to tasting fat, which is interesting. Now, from an evolutionary standpoint, why would we have taste? Well, sweetness helps to identify energy-rich foods. What does that mean by energy-rich? Glucose, carbs, right? So anything sweet, of course, is going to have a lot of sugar. Whereas bitterness served as a warning sign of poison, which is very interesting. Our ancestors avoided this stuff like the plague because typically it was poisonous. Nowadays, there's foods that are bitter that we do enjoy in our daily diet. So, for example, I like Brussels sprouts, but I understand a lot of people don't like them because they are rather bitter. Same thing with coffee, especially black coffee. If you're not a fan of black coffee, it can be associated with the fact that it's bitter. After age 50, loss of taste occurs due to the breakdown of the papillae and decrease of saliva production. We're going to talk a lot more about that when we discuss smell as well, because these two things are associated. And some fun facts. Rodents, so mice and rats, they have the ability to taste starch. I know we like our potatoes. We also like our rice. But if you ever bite into a potato by itself, no spices, no nothing, it's rather bland, no real taste. And it's because we can't taste starch. And finally, cats have the inability to taste anything sweet. So that's interesting. They cannot taste anything sweet. Okay, some functions of the tongue, straightforward enough. The tongue moves and pushes are a couple things to discuss. Eating, speech, and taste. Obviously, taste, we're talking about taste right now, so that's common sense. But from eating perspective, we're going to learn more about that when we do digestive system. The tongue moves and pushes a small bit of food along with saliva into your esophagus, which is a food pipe that leads from your throat to your stomach. So you're moving this stuff along, and we'll learn all about that. The tongue literally molds the food. Speech, on the other hand, is very, very incredible. The tongue has to move in such a way in order for you to manipulate the sounds you're making in order for you to make words. And most of the English language requires, and most of any language for that matter, requires your tongue moving in such a way, especially pressing against the roof of your mouth, to make these intricate sounds. This is what we were just talking about previously. Or actually, I may have skipped this, sorry. The papillae here you see are the grooves in the tongue. They're surrounded by these taste buds. So the idea is that when you eat something, right, when you're eating something, should I say, chemicals of it interact with your taste buds, and your taste buds convert that into an electrical stimuli to send to your brain, and then your brain can receive it and say, oh, this is what I'm tasting. And that's what we see here. Finally, to conclude for this video, this is a common myth that is just one of those things that's just mind-boggling to me that still exists, that people still believe this. But for many years, it was taught, because this is literally how I learned it in elementary school, that we have regions of the tongue for numerous tastes. As it turns out, it's more of a spectrum of tastes, with certain areas having stronger connections with certain tastes. So I was taught literally that the tip of the tongue, for example, was where salty food is tasted. And that the sides of your tongue was where sour and bitter foods, and that the back of your tongue was more for sweet and also bitter as well. It's not like that at all. You have areas of your tongue that are sensitive to certain tastes. So, for example, the tip is more sensitive to saltiness and umami, but you still pick up sweet, sour, and bitter. It's the same thing with the sides, same thing with the back. It's a common misconception that unfortunately has gone on for little too long. All right. So that's what we're going to conclude for today. Thank you for tuning in. I will see you on the next one.